Before we talk about the future of data modeling, let's go back in time, back to the year 1859. Charles Darwin, his book, The Origin of Species, was just released. And in this book, he talks about a really controversial topic, the theory of natural selection. In the theory of natural selection, he puts in this book that really the way species survive through generations and generations is by adapting to their environment. For example, the peppered moth you see here. In Industrial Revolution England, a lot of pollution in the air. There are two types of peppered moth, a lighter one and a darker one. The trees became all covered with soot from pollution, and so the darker colored moth was able to camouflage themselves and be able to avoid predators. The lighter colored moth, on the other hand, got gobbled up. And as generations of moths were produced during this time, moths became darker and darker and darker and were able to adapt to their surroundings, and the light-colored moth became extremely rare. About 100 years later, the Clean Air Act passed in 1956, and the reverse actually happened, where because there was less pollution, there was less soot on the trees, and the moths that were lighter in color were able to better hide from predators, and the darker colored moths became increasingly rare. So this theory of natural selection applies to all species, including the species of data modelers, which we'll talk about today. So I'm going to talk about the data modeler of 2020. Now you might be thinking, okay, why does Steve Hoberman know the future? How can I predict the skills and the adaptations the data modeler of 2020 is going to have? And it's a really good question, because if you saw things like, for example, what stocks I bought or what stocks I sold, you would know for sure I have no idea what the future is about. I mean, every company I've ever bought stock in, the company's gone out of business or awful things have happened. I'm awful with investing, for example, but my whole life revolves around data modeling. So I've become very adept at seeing what's happening in our field. And there's three reasons why I believe I could predict the future for data modeling and data modelers. And the first is because of my history. So I started data modeling back in 1990 for Bell Labs. Spent about 5 years there, and then 4 years on Wall Street, and a little under 10 years for M&M Mars, a candy company, and lots of consulting projects and so on since then. And over this period of 25 years of data modeling, I've seen a lot of changes to our field. And I've seen certain things that have come and they were fads and they disappeared quickly, and certain things that stayed around for a while and we needed to adapt them as part of our toolkit. For example, if you've been in the field a while, you may remember the information engineering phase back in the late 80s, early 90s. And that was more of a fad. It came and it went. But then you have dimensional data modeling, which came and it stayed. It was something we needed to evolve to and adapt to. And there's lots of things like that have come and gone, and certain things we have to adapt to. So because I know the past pretty well, I can make very good projections about the future. The second reason I believe I could predict the future is because on an average year, I come into contact with over 1,000 people in our field. People through my data modeling training classes, people through consulting assignments, across every industry around the world, and I hear challenges that they're facing and opportunities that they have. And I listen and I see connections across a lot of these assignments. Helps me to understand what's happening. And the third reason I believe I could predict the future for data modeling is I have a brother who is CIO of a major Fortune 500 company, and I talk to him a lot about what he sees in terms of technology in the future. And it's really interesting having his perspective and my perspective and being able to make those sorts of connections. So I see 5 adaptations we need to make as data modelers by 2020. And these are not listed in order of significance. They're listed in just the order I'm going to go through them in this presentation. Become a data structure scientist. Ride the wave caused by the perfect storm. Learn a graph or document database. Master a fact-based modeling dialect. And build and maintain the enterprise logical data model. So I'm going to go through each one of these in this talk. The first adaptation we're going to talk about is for us to become data structure scientists. And what do I mean by that? Well, think about our term, data modeler. And how do we become data modelers? Did we graduate from college with a degree in data modeling? I mean, there's degrees in accounting, so people become accountants. There's degrees in law, so people become lawyers. Did we get a degree in data modeling? Well, no. Well, what about our moms and dads? Were our moms and dads data modelers, and maybe we inherited data modeling from them? I don't think so. We became data modelers because we have a very important skill of taking complexity and making it simple for people to understand. We have the skill of looking at the world being very ambiguous, and maybe there's confusing requirements or conflicting requirements or no requirements. And we look at this complex environment and we're able to organize it with a few symbols and create a very simplistic picture of it. And that's a real skill. That's what we do as data modelers. And it's actually not that different from what a data scientist does. A data scientist looks at incredible complexities in data to try to extract understanding, and we do the same thing for the structure. We will look at the structure and try to extract understanding. So this first adaptation is to realize that as data modelers, we can use our skill of taking the complex world and making it easy to understand. We could take this skill and apply it to many more things than just building relational data models that wind up in a relational database design. So the term data modeler sounds so confining. The term data structure scientist is where it's at. And I'm not saying that we should change our job title to data structure scientist, although it does sound pretty cool, and data scientist is just a really cool term for most of the time a statistician. So data structure scientist could be a really cool term for a data modeler, but even if we keep the data modeler term, what we need to realize is our skills are applicable to lots of other areas rather than just building relational databases. And to give you an example, let's go back in time. So let's go back to the year 1735. Leonhard Euler, who I believe was the first official data modeler, did something really cool. So he was a famous mathematician, and there's this town called Königsberg, which was in Prussia. Now it's in Russia, and the names have changed, but the ideas that he brought up in 1735 have stayed the same. And what he said was, here's this town called Königsberg, and it's a town that has two large islands in the middle, and then there's 7 bridges that connect these 2 large islands to the mainland. And he said, well, how can we cross all 7 bridges without crossing the same bridge twice? And we cannot backtrack. We have to cross each bridge only one time. How can you do this? So he did something really interesting. He considered this a mathematical problem, and rather than look at the city and think about ways to do this, he did something really neat. He looked at this problem of crossing the bridges, and he said, in order to solve the problem, we could come up with very simple symbols that represent these geographic components, and then we could look at these geographic components and try to solve the problem, try to explain the complexities without looking at the real thing. So, for example, instead of looking at a landmass, like one of these islands, he would have a circle. Instead of looking at a bridge, he would have an edge or a line. And so, even though in this white paper he wrote back in 1735 describing how to cross the bridges, he made the assumption that you cannot cross all 7 bridges only once and not backtrack, and that turned out to be incorrect years later. What he did bring up in this white paper is the idea of keeping things simple, looking at something complex and representing it using just a few symbols. That's why, and actually this white paper if you research it deeply, you learn that this is really the birth of a whole bunch of different disciplines like graph theory, network theory, topology, because he was able to take the real world and show it using different symbols. He was able to organize things and create a very simplistic view of this complexity, which is why I also think this particular white paper he wrote in 1735 is the first white paper on data modeling. It's the same idea I talked about a minute ago, where we have the skill of representing complex things in very simplistic ways. That is what Euler did, and that's what we do on our projects. So if you look at what we do as much more than designing relational databases, we could redefine data modeling. We could redefine it as a process of representing real-world complexity in a precise and simple form, which is the data model, to solve important problems, to meet business challenges. Is a more positive way to say it. But really, it's the same thing what Euler did with the bridges we do on our projects. We're thrown in this complexity, and we have a certain skill of organizing things and being able to describe it using just a few symbols. And that's the skill of modeling. So what am I doing? What is Steve Hoberman doing to become more of a data structure scientist? And not changing my job title, data structure scientist. I am a data modeler, but being able to apply my modeling skills to other areas. So one of the things I'm doing is I'm taking consulting assignments where I'm using my modeling skills in non-traditional ways. For example, this summer, I took on an assignment with an insurance company where I looked at some very complex artifacts they had, an enterprise data model, business intelligence, conformed dimensions, a data governance glossary. I took these different artifacts, each being fairly complex and comprehensive, and I used my modeling skills, my skills at simplifying things, to build a conceptual data model. And on this conceptual data model, this CDM, I show the overlaps and inconsistencies across these three artifacts. So that's an example of what I'm talking about, taking our skills and being able to apply them to different areas. Just what the data scientist does, going through data and trying to look for patterns, for simple trends, we're doing that with structure. We can go in, look at the ambiguous world, and come up with simplistic representations of it. The second adaptation we can make to become the modelers of 2020 is to ride the wave caused by the perfect storm. And this is a picture here of our New Jersey beach house after Hurricane Sandy hit. This is actually part of the property that was the least destroyed. Just to give you an idea that whatever I invest in does become a complete disaster. Every stock I bought, we decided to take our savings and buy a beach house about 4 months before Hurricane Sandy. And then Hurricane Sandy hit, and different perspective then after Hurricane Sandy. So anyway, it was a perfect storm, Hurricane Sandy. It was powerful winds, it came during high tide, it moved really slowly, so it did a lot of damage. And I actually believe there are a couple things on the horizon that also have the potential to be a perfect storm. So here I am surfing. Well, maybe it's not me, but it looks a little like me. So anyway, there's three activities, three trends going on now that could really help cause the perfect storm: agile, cloud, and big data. And what do I mean by this? Well, agile's been around a while, and it could be applied very, very successfully. It could also be applied with disastrous results. I've seen agile applied where the saying, face-to-face communication over written documentation is interpreted to mean that there is no documentation. And therefore, it's very easy to build projects without doing any kind of modeling. Luckily, though, there's often pushback on that. There are people who are aware of the project, and they could meet with project managers and business sponsors and encourage the agile project team to do better documentation so it's easy to maintain over time. We could help with structures, improvements, that sort of thing. So it's always nice to have those checks in place where we're aware of the projects. Cloud comes along, and cloud says really you could store some of your data outside your organization. And what that allows project teams to do is to be able to circumvent some of the checks and balances so that certain projects could be produced without even an awareness of them. And then big data comes along with a lot of really easy to use tools, easy to use data processing tools and transformation tools and analytic tools that allow us to circumvent a lot of the traditional database type tools. So the reason I call all three of these the perfect storm is it gives project teams the opportunity to completely circumvent any checks and balances in our organization. Project teams could build applications without the data modeler being aware, without the database administrators being aware, without any data managers, data architects being aware, by using these three together. So that's why I see these as a perfect storm. Luckily, we could ride this wave. There are a couple things we can do. I'll talk about three things we can do to work with project teams to build successful applications and not cause anything like the damages of Hurricane Sandy. So the first of these three to ride the wave is for us data modelers, to become more agile. So here I am in a race a number of years ago looking like I could win. I didn't come anywhere near winning, but what I mean by us becoming more agile is that instead of going through rigorous second normal form, third normal form, high-level dimensional kind of processes and techniques, we could look at what we do as really an iterative cycle of eliciting information and then documenting it. So I've been teaching data modeling for a long time, and this past year in our 5th edition of our training manual, what I did is I stripped out a lot of the traditional data modeling syntax, and I introduced a whole bunch of different templates that are agile, meaning that if somebody fills them in, somebody who maybe doesn't even have 10 years of data modeling experience fills these in, they can complete the data modeling deliverables. And I got this idea from a book that I wrote that was released this past year called Data Modeling for MongoDB, where one of the main audiences for this book are developers to learn more about data modeling. And I could not see myself describing normalization to MongoDB developers, but what I could see myself doing is taking everything behind normalization and other data modeling techniques and making them more agile by making them template and question driven. Because really when you think about what we do, we really have this iterative cycle where we elicit requirements, we ask questions to people, and then we document them. And documenting them on our data model means that we're increasing precision. And a lot of times when we do that, new questions come up, and it causes this cycle that continues until the modeling is complete. So we can have more templates and more spreadsheets for people to fill in to help us become more agile. And I'll give you an example of some of the templates that I've been using. So, and this is in my training manual. It's also in the MongoDB book. So when I build a conceptual data model, what I've been filling in is very simple spreadsheet. Who, what, when, where, why, and how. Where whenever I come across a person or an organization of interest to the enterprise, I put that who in the who column, so customer. And what represents the products and services that an organization offers. So account, for example, is a what. Product, service, or what's. When represents two aspects of things changing. One is time, temporal data, like dates, account open date, and the other aspect of when is life cycle or state changes, known as bitemporal. So if I'm tracking how something changes over time, the life cycle something goes through, that would also be a concept I would capture in the when column. Where includes everything to do with location. It could be actual locations like warehouses and branches. It could be virtual locations like websites. Y captures the notion of an event or a transaction, like check debits, deposit credits, orders, credits, that sort of thing. And how captures the paper trail that documents the why. So if there's an event that takes place, somebody cashed a check, the how is because there was a check written. That was the paper trail. So this template here can help anybody quickly scope the concepts that would appear in a conceptual data model. Another idea of a template that I use on the conceptual is to create relationships. What I do is I would ask certain questions to decide what the cardinality, the symbols would be on the relationship lines. So this is an example where, okay, can a customer own more than one account? So if the answer is yes, I'm going to have a many symbol next to account in the relationship. And can an account be owned by more than one customer? The answer is yes too. So we're going to have some kind of many-to-many relationship between customer and account. And then the next two questions talk about whether there's a need for optionality, where we should put zeros on the relationship line. Can a customer exist without an account? Can an account exist without a customer? That will tell us where the zeros go. And then the next two questions, are there examples of customer? Are there examples of account that we would like to show? This tells us if we should add subtypes. For example, maybe there's examples of account, like checking account and savings account and brokerage account, that would be valuable to show. So then these would appear as subtypes. Also, the next two questions, does a customer go through a life cycle? Does an account go through a life cycle? This too helps us understand if we should add subtypes. If a customer can go through a life cycle, maybe a customer starts as a prospect and then becomes a customer, those might become separate subtypes. So by asking questions like this, and by having someone just check off yes or no for the answers, we could translate it directly into the data model. One more taste of a template I'm doing. This has more to do with the logical data model than the two previous where I used for conceptual. Here, for example, in order to brainstorm on the attributes I need for each entity, I will create a template like this where the rows represent high-level domains or class words like name, text, amount, date, and so on, and the columns represent the entity names. Like entity A could be customer, and if we want to store, what names do you want for customer? Well, I want their first name, their last name, then I'll put it in that name cell under customer. So this becomes a very good brainstorming techniques. What text do you need to know about customer? What amounts do you need to know? What dates do you need to know? These all help me come up with a really, really good initial list of attributes for my logical. So that's an idea of some of the templates that I use. The second area where we can ride the perfect wave is by becoming a DBA. And by DBA, I don't mean database administrator, I mean database architect. There's a real need for in organizations, and I see this on a lot of my consulting assignments, to help teams decide what types of technologies to use. The biggest one is shown here on the signpost. Should we use a traditional RDBMS like Oracle, Teradata, and so on, or should we use one of the alternative technologies, a NoSQL like MongoDB or Hadoop? So when do we go MongoDB? When do we go Oracle? I'm not sure. And somebody needs to come up with rules when we go each route. And I think because of our abilities to take complexity and bring simplicity to it, I think that we would be great candidates to be a database architect. And not just for RDBMS versus NoSQL, but the other parts of the perfect storm too. So for example, should we go cloud or should we not go cloud? Should we go agile or should we not go agile? We can have decision trees for those options as well. So what am I doing in terms of riding the perfect wave? In terms of becoming a DBA, database architect, I found that on a few of my recent consulting assignments, people would ask me to come up with those initial guidelines. When should we go MongoDB? When should we go Oracle? So one of the things that I'm doing is I'm formalizing these decision trees. Now, of course, as technology changes, these decision trees have to change too. But a lot of the principles around integrity and availability don't change. So we would be great candidates to build decision trees like these. So in addition to coming up with templates, in addition to being able to create decision trees, another way we could ride the perfect wave is by sharpening our influencing skills. We're going to need to become better and better at convincing project teams of doing the right thing, of when to use templates, when to use agile, when to use the cloud, when to use big data techniques versus traditional techniques. And so we have to work on our influencing skills, something outside of technology. These softer skills are really, really important. And one of the things that I've been doing to improve my softer skills and also those of fellow data modelers is I chair the annual Data Modeling Zone Conference. And at this Data Modeling Zone Conference, we bring a lot of different sessions in every year that sharpen our data modeling skills. So a lot of these sessions have to do with more technical skills. But we're also starting to introduce some softer skills. So for example, at this past year's Data Modeling Zone, we had a very famous arbitrator come in from Washington, D.C. He does a lot of negotiating in Washington, D.C. And he came in to help us understand how to negotiate as a data modeler. And we had a number of sessions like this. Have to improve our influencing skills. Number 3 adaptation is to learn a graph or document database. I'm not saying to become an expert in one of these databases, but I am saying we need to be knowledgeable how they work. At a minimum, we need to know how to forward and engineer from our logical models to these NoSQL databases. That's a real gap in a lot of organizations. Is there are teams that are building now MongoDB, Hadoop, Neo4j, Cassandra, all these NoSQL technologies, and not building the proper models behind it. And so as data structure scientists, as data modelers, we need to know, at least at a minimum, how to connect what's being done out there to what we do when we do a logical data model. How do you go from a normalized logical data model to an Hadoop implementation? And that's what we need to do. We need to do that. We need to fill that gap and be able to critique physical designs in these other technologies and make sure they're consistent with how we intended our logical model to be implemented. And actually, we would be great at learning some of these technologies because everything we do, as you saw, for example, with the 7 bridges of Konigsberg, everything we do in terms of taking complexity and representing it in simple forms ties back to mathematics in some way. The graph theory back to 1735. Everything we do with normalization, really, it predates Chris Date's paper on normalization by over 100 years. What we do in normalization is really set theory, and that goes back to 1870. And hierarchies, we deal a lot with hierarchies. That goes back also to the 1800s, 1880s. So I actually think we would have the perfect mindset to pick up some of these newer technologies. Not all of them. I would recommend either a graph or a document-based technology. There are 4 that are out there. You have graph, document, key value, and column. Key value and column have more to do with how the data is stored, in my opinion. Graph and document have more to do conceptually, which is with how you would explain the data to people who don't even know the technology. Kind of like how we would handle set theory. If we know set theory, we can pick up graph theory and document theory. So I actually think 2 very good places for us to start would be Neo4j, which is a graph database, and MongoDB, which is a document database. These 2 organizations, Neo and MongoDB, they have a very large following. They're easy technologies to learn. And what am I doing is, well, I spent quite a bit of time learning MongoDB myself. And my driver for learning it is I wanted to make the connection, just like I mentioned on the prior slide. How does what we do in conceptual and logical modeling relate to a MongoDB physical design? And so I wrote the book for that. And I had to do a lot of research in writing this book. So that's the kind of things we need to do. It's not necessarily write books in different areas, but make these connections between what we do in logical modeling and these technologies. MongoDB is really easy to learn, and there's so many good resources out there. You can buy my book, but there's also a lot of things available online to quickly get started. I mean, I had the MongoDB server and client running on my laptop within about 2 hours after just learning about the technology. So really easy to get up and running. One of my New Year's resolutions, one of the goals I set myself for 2015 is to actually learn a graph database. And so I am going to teach myself Neo4j this year. I think that would be a great one to learn. And my goal for learning, just in the theme of kind of learning more about these technologies, just in that theme of not becoming an expert. I don't expect to become an expert in Neo4j, but I do expect to be able to take what I do as a data modeler during the logical modeling phase and connect it, see how it relates to a Neo4j. Connect it means I should be able to know how to forward engineer a normalized logical model into a physical Neo4j graph design. And the other way too, I should be able to look at these graph databases and be able to reverse engineer them up into a logical design. The fourth adaptation is to master a fact-based modeling dialect. So what is fact-based modeling? Fact-based modeling is a technique of building designs based on using semantics instead of structure. So you know how we traditionally would build a data model. We would talk to some experts and they would start talking about their business, and we would create structures based upon their business. Like they would talk about Bob the customer, and so we would create a customer entity, for example. With fact-based modeling, the conversations that go on with the business experts are more semantic than structure. They're more talking about Bob the customer than the customer themselves. So if we were building a model for a building, for example, some of the statements we would document to build our model would be things like floor 1 exists. Floor 1 has 2 emergency exits. Room 1.1 is 20 seats. Room 1.1 is equipped with the facility PC. Instead of looking at it in terms of structure, like floors and exits and equipment, we would look at it in terms of data semantics. And I think that's a wonderful way to complete the data modeling process, is to work with business experts and actually extract out how they see their world and then put it into the form of a model. You see a sample model here. This is a fact-based model here. There's lots of variations in different techniques like ORM, FCOIM, and others. And I'm not saying necessarily to follow the syntax of the model like you see here, but what I am saying is I think it's very, very useful for us to use the technique of modeling by example. Use the technique of talking about instances, floor 1 instead of floor. And the reason for that is a lot of these newer technologies have more to do with data than structure. You might have heard terms like schemaless or no predefined schema. So a lot of these newer technologies encourage just jumping into the data. And for us to adapt, I see techniques such as modeling by example, modeling the data instead of the structure, being really, really useful. And so what am I doing to adapt to this challenge is, well, going back to our data modeling zone, DMZ conferences, I've been bringing in experts in the area of fact-based modeling to talk to us and explain how to use it. So, for example, at this past year's DMZ, we had Terry Halpin and Gordon Everest come in and talk about object role modeling, ORM, as one of the fact-based modeling methods. We also publish books, and I am working with Terry Halpin to publish his next 2 books on ORM. And these ORM books are designed to be more of a guidebook, short guidebooks on how to apply ORM, which I think would be great to help us connect everything going on with these newer technologies to what we do in modeling. The 5th adaptation is to build and maintain the enterprise logical data model. Enterprise data models have been around a long time, and they used to be really, really popular back in the late 80s and early 90s. And I think the reason for that popularity is because we were building a lot of new applications and we needed some way of retaining control of all the data that's out there and being able to do some impact analysis and find, gee, we have an attribute called customer last name. Here's all the places it lives. We needed that big picture. We needed to manage the lineage to all the different applications. It's really important. And enterprise modeling kind of fell out of fashion for a number of years, but it's coming back extremely strong. And the reason that I know that is because in my last few consulting assignments, and I have already one scheduled for early next year, they're all focused on the enterprise data model. And I think at the logical level is really where it has to be built. So much like this image here, which is the cover of one of our books, Connecting the Data, we need to be able to take this chaotic world out there and be able to explain a single view of all this information to project teams, to management. And usually what I'm seeing now is these enterprise logical models have very much a future view of the world. They're not necessarily showing the as-is state. They're showing where the organization should be 3 years from now or 5 years from now. So there's a lot of projects out there. And some of these projects are traditional RDBMS implementations like Oracle, Teradata, and so on. And some of them are NoSQL, like Hadoop, MongoDB, and so on. So these typical RDBMS projects and some of the NoSQL projects will follow the normal modeling steps we do with any project. We'll build a conceptual to understand the business needs. We'll build a logical to understand the business solution. We'll build a physical to understand the technical solution. And some projects out there that are NoSQL based will skip the logical, hopefully at least have some logical. Some will skip it altogether, but some will have a logical. And these logicals should be more fact-based modeling, FBM, like we talked about in the last adaptation. And eventually there's an implementation. So some NoSQL projects are going to follow the standard way we model, conceptual, logical, physical. And some are going to take a very streamlined approach, maybe skipping conceptual, maybe skipping logical, maybe doing a fact-based logical model and then going to implementation. Lots of projects out there. And so where the enterprise logical sits in is right in the middle, where we can build a conceptual enterprise logical model. And you see the two-way arrows indicate mappings back and forth with the project model. And also we have a two-way arrow with a logical. Sometimes we may learn something in the logical, update the conceptual. More than likely we'll come up with something in the conceptual and then add that to the logical. So these arrows show us lineages and flows between the different models. And the enterprise logical sits right in the middle. It's almost like the hub of a bicycle tire. You need that enterprise model in the middle, and the spokes represent the linkages between the different project models. So it's such an important deliverable, and I'm really, really, really glad to see so many of my recent assignments focused in this area. A lot of teams now are building enterprise models, and it's about control. It's about saving maintenance costs in the future. It's about reducing the amount of time it takes to build a new system because I could start with something existing in the enterprise model. It's about common language and so many benefits of it. It's wonderful to see it really taking hold again. So what am I doing to adapt to this enterprise modeling trend? Well, I manage the publishing company Technics Publications, and recently I actually built an enterprise model of my publishing empire to help with improving some processes. The boxes you see yellow here was originally a weak spot in my organization, and I used modeling, enterprise modeling, as a way to uncover the weak spot and find a solution. That's one example. I also noticed a lot of my consulting assignments focus on the enterprise model, and that's also ways to adapt and get the big picture. So just to summarize, if we make these 5 adaptations, we'll be thriving by the year 2020 comes along. Become a data structure scientist, And remember, I don't mean necessarily changing our job titles from data modelers to data structure scientists. What I mean by that first one is being able to take our skill of simplifying things and applying it to different areas. Ride the wave caused by the perfect storm. So when agile, cloud, and big data come along, we could ride that wave. We could come up with agile modeling techniques. We could come up with ways to reduce the amount of time it takes to build a system through templates. We could practice influencing skills, for example. Learn a graph or document database, not necessarily become a Hadoop or MongoDB expert, for example, but at least understand how these technologies work so we could connect them to our logical models and forward engineer from logical to a NoSQL database and reverse engineer from a NoSQL database back into a logical. And master a fact-based modeling dialect. I really think modeling by example is a great way to elicit requirements, and then in many cases when we're dealing with some of these newer databases that are schemaless, these fact-based modeling techniques work really well with them. And then build and maintain the enterprise logical data model. Someone needs to maintain control of the data and know the future state of an organization and know all the linkages to the current systems, like where is customer last name, where is customer first name, and that's what the enterprise logical data model does. And so it's becoming very, very popular again, which is wonderful to see. And I think it will continue to get more and more popular. So coming back to these peppered maws, hopefully we understand natural selection and how it relates to us, the modelers. And there's very, very small steps we could take to adapt and become successful and thrive for 2020 and beyond. Thank you very much.